Okay, so we finally made it to our last set of notes for Unit 7. And this set of notes talks about two common problems when we do test of significance. And so let's just think again about what a test of significance does, right? It tells us some story about the population parameter, whether that's the percent for the whole population or the mean for the whole population. And it tells us if that percent or mean is equal to, not equal to, greater than, or less than some claimed value. And so, and it does the same, for a difference of two populations. So when we take two samples. And so sometimes when we do a test of significance and we run a confidence interval, we make the wrong conclusion. And that's not because we mathematically did anything wrong. It's just because our data maybe was biased or our sample wasn't great and something happened to tell a false tale about our population. And so we summarize these problems with type 1 and type 2 errors. And so a type 1 error occurs if we reject the null when it was actually true. All right, so this would be if we reject the null hypothesis in favor of the alternate, but we should never have rejected because that null was actually true. The type 2 error is the opposite. That happens if we reject the alternate, or I'm sorry, we don't reject the alternate, we fail to reject. That's our other option. When it is false. All right, so it should have been rejected. I guess that's an important thing. And so this table summarizes what we just wrote, right? So a type 1 error happens if we reject the null when the null was true. And a type 2 error occurs if we fail to reject the null when the null is false. All right, and so the other two opportunities, the other two things are when we do the right thing. We reject when we should have, we fail to reject when we should have. All right, and so the probability of a type 1 error is the level of significance alpha. And so that's why we use such a small level of significance, right? We use 0.05 or 0.10. We don't want to have a very high likelihood of making that error. So we use a low level of significance. Then the probability of a type 2 error depends upon the power of the test. Now, power is a thing we could calculate, but it's not our job to calculate it in AP Stats, so we don't. All right, but what we have to know is that the probability that a type 2 error occurs is equal to 1 minus the power. So we want a really high level of power in our test so that when we subtract it from 1, that type 2 error probability is very small. All right, so I think all of the problems we're looking at today are familiar to us. We've done tests of significance, and so now we're just analyzing what these errors would look like. So here we're looking at the potato chip producer. They agree with their main supplier that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make the decision, a supervisor will inspect a random sample of potatoes from the shipment. The producer will then perform a significance test using the hypotheses. These are important. P equals 8% and then P is greater. Remember, this is the problem where we are checking to see if a sample of potatoes from the truckload have a higher percent than 8% in terms of blemishes. If so, they send it away. If not, they use those potatoes to make potato chips. Describe a type 1 error. So remember, a type 1 is when we reject... Oh, goodness. when it is false. I'm just reminding us, right? And so a type 1 error would mean we say that P is greater than 0.08. That's what it means to reject. We conclude the alternate is true when P is actually equal to 0.08. And this should say P is true. We should not have rejected. Okay, and so let's think of the ramification of this. What does this mean? Well, if we claim that the percent is greater than 0.08, when really that percent is equal to 0.08, we would send away a good truck. Right? Our conclusion says send that truck away. P is greater than 0.08. But that was the wrong conclusion, and in fact, P is only equal to 0.08. Now, a type 2 error is the reverse. It's when we fail to reject the null when the null is false and should have been rejected. And so this would mean we say the exact opposite. We say P equals 0.8. We keep that truck when in reality P is greater than 0.08. Okay, so here we are keeping a bad truck. All right. Now we could talk about which is a worse mistake here, right? Type 1 error causes us to send away a good truck, which costs us money, time, energy, all of that. Whereas a type 2 error causes us to keep a bad truck and make potato chips with bad potatoes, which is not great either, but for different reasons. All right, example 2. This is the AAA battery example. I'm not going to read you the whole paragraph here, but basically we have to know that our null hypothesis said that P equals 0.25, and our alternate would say that P is greater than 0.25, where P is the true percent of performance time that a new battery lasts longer or compared to the existing. So if P is greater than 0.25, then it lasts more than 25% longer than the other batteries. So a type 1 error means we reject the null. So we conclude that P is greater than 0.25 when we should not have rejected the null because P is equal to 0.25. Now, what does that mean? We are claiming that the batteries last longer than they do, right? We are saying that that percent that they last is longer than 25%, longer than the other batteries, when they really don't. So we claim the batteries last longer than they actually do. A type 2 error is the exact opposite. So a type 2 error would be when we say P equals 0.25 when P is actually greater. Okay, so this means we claim the batteries don't last as long when, or maybe as they actually do. All right, and so now let's talk about the ramifications here, right? So if we say they last longer than 25%, longer than the other batteries, when they really don't, we might be selling batteries using false advertisements, saying they last much longer than they actually do, and we might have some angry customers. Whereas on the flip side, if we find, hey, these batteries don't last as long as we need them to, we might go back for more testing. We might go back to redeveloping batteries and waste a ton of time, because in actuality, they do last the length we were hoping for. So again, both types of errors cause problems for companies or medical studies or whatever that's about, but they just have different ramifications. Sometimes it could impact a customer or a patient. Sometimes it just impacts the business or the doctors or whoever's in charge. Okay, oops. Last but not least, Simon reads a newspaper report claiming that 12% of all adults are left-handed. So this is that example, left-handed. He wonders if 12% of the students in his large high school are left-handed. He chooses a simple random sample of 100. Okay, so now this one did not give us the hypotheses, but the good news is we don't need it, right? It says he chooses a simple random sample of 100 students and records whether each student is right or left-handed. He then runs a test of significance using a significance level of 0.05, and he notes that the power for the test is equal to 0.80 or 80%. Remember, the probability of making a type 1 error is equal to alpha, the level of significance, which is 0.05 or 5%. Not very high, right? And then the probability of making a type 2 error is equal to 1 minus the power. So 1 minus 0.80, which is 20%. A little higher. Okay, so type 1 is when we reject and we shouldn't have. Type 2 is when we fail to reject and we shouldn't have. Usually these questions about type 1 and type 2 errors show up as multiple choice questions on the AP test, but it's good to be able to explain them, so be prepared for short answer as well. All right.